if you have an object in front of you and you don't know what type it is, there's actually a nice function in Python that tells you the type. The function is called type, surprise. So if you want to know what's the type of the object 8, you can write type 8, press enter, and it tells you the type. This is actually the same result that you can see here in the variable explorer in the column type. Now all these values here, 13, 16, 8, are all ints. That actually is an integer. Integers are abbreviated with int, and basically on integers you can perform all the typical mathematical operations like addition, subtraction, multiplication. So for example, if we write 3 times 4, that obviously tells Python to multiply 3 with 4, the integer 3 with the integer 4, which gives you the result integer 12. Integers are very common in Python. They are also the output of many functions, in particular functions that count things. A very similar data type, but not entirely the same, is something like 2.5. 2.5 is also a number, you would guess, but if you ask Python about the type, 2.5 is a float. As integers, floats are numbers, but in contrast to integers, they come with decimal places. But they behave very similar to integers in many ways, because all the conventional mathematical operations can be used with floats. If you want to transform one data type into another, there are also Python functions that do that for you. So for example, let us associate x with a value 2.0. If we ask Python about the type of x now, it will tell us that it is a float. We might want to turn x into an integer. We can do this by using the function int and then enter x. If we execute this, then Python returns as x transformed into an integer. Now keep in mind that if we ask Python about x again, then it's still a float because we haven't changed it. If you want to change the association of x, you can do this, but you have to do that explicitly. If you execute this code and now you ask Python about the type of x, it actually returns that it's an integer. Transforming one data type into another one is sometimes very important, but can also be dangerous. For example, what happens if you have a variable y, 2.8, and you want to turn this variable into an integer? Python has very strict rules about what it does when you transform a variable into a different type, and if you transform an integer into a float, what Python does is just strips away the decimal place. So you might want to have expected that this returns 3 because actually Python seals to the next integer, but it doesn't. It just simply strips away the decimal places. This is important to keep in mind. The next primitive data type we will learn about are strings, and they usually behave very differently than integers and floats. Probably the best way to think about strings is to think about them as words. You define a string by using quotation marks. So in this case here, x is of type string. It is very obvious that strings behave very differently than integers and floats. So for example, the conventional mathematical operations are not defined for strings. So for example, suppose we have here x associated with the word hello and y associated with the word world, and then we try to subtract y from x. This obviously doesn't work. So what comes up here is a type error, and Python tells us here that what the operator minus tells it to do cannot be done for strings. I mean, it's a really hard thing actually to subtract the word from the word hello. It doesn't make much sense. At the same time, other mathematical operations are defined for strings, or it's better to say that actually the operator plus has a certain or conducts a meaningful computation if used in conjunction with strings. So for example, if we actually use the operator plus with two strings, what Python does, it concatenates the two strings. Sometimes it's also it works to use different types with each other. While it does not work to add 5 and x, we can actually multiply 5 with x being a string here. What happens in this case is that Python just creates a new string, which is a concatenation with the old strings, but 5 times in a row. This is very often very useful, and it is actually also a nice example for a case where integers and floats behave differently, because while this works for integers, it does not work with floats. Here Python tells us that it can't multiply a sequence of non-int of type float by non-int of type float, which basically means it knows how to write hello 5 times in a row, but it does not know how to write hello 5.0 times in a row. The final data type we will learn about are Boolean values. The nice thing about Boolean values is that there are actually only 2 of them, true and false. Boolean values occur most naturally if you test for relations such as greater than, smaller than, or equal to. So for example, if you ask Python, is 5 smaller than 9? Well, Python tells you, yes, that's true. If you ask Python whether 5 is bigger than 9, it tells you that then that is false. Now, what is very useful about Boolean values is that you can actually add them up. And if you add them up, then true always counts as 1 and false counts as 0. This is very useful in many instances, which we will learn about below.